This unit is 6.2, and it talks about powers of monomials. So I want to highlight this is the most important part, the powers. So we're really talking about these little things that I highlighted. It says that to raise a monomial to a power, use the power rule, which states x raised to the eighth, then raised again to the bth, we have to use multiplication. Therefore, it's called power rule. Where does this come from? I'll give you an example on the side. Think about it this way. If I do 2 squared, I raise it to the power of 2, then I raise it again to the power of 3. So isn't this saying it's 2 squared multiplied by itself 3 times? That's how I rewrite the power of 3 there, right? Then I know let me change the color. I know that 2 squared is 2 times 2, and here's 2 times 2, and here's 2 times 2. 1, 2, 3, 4, 5, 6 is 2 raised to the 6. Isn't that the same as 2 raised 2 times 3? That's how I get that. Okay? So do not get confused with this. If I have x raised to the power of 2 times x raised to the power of 3, I have the same base. Remember? That has the same base. When I have the same base, I add the powers together. And so my final answer is x raised to the 5th. So that's different from the power rule. Now that we know the power rule, again, power rule has one base only. It's not separate terms. It's one term raised twice. So you just multiply them together. So in this case, this example here, you should have x raised to the 10th. And you have multiple variables. Be very careful. What you do there is you rewrite them. You distribute that 4 to both variable. And now you should have m raised to the 28th times n raised to the 16th. Okay? CD squared raised to the cube, and that cube needs to be distributed to both. And your final answer is c cubed times d to the 6. Okay? Same thing with coefficients. You raise the coefficient to the power, just like how we treat different variables. That outside power needs to be distributed to each variable, each term, and each coefficient. And then you simplify the variable. So in this case, the 2 has to be distributed to the 5, and then x raised to the 7th. Make sure to protect it with parentheses, and you should have x raised to the 14th, right? So this is 2 raised to the 5th times x squared raised to the 5th times y raised to the 5th. And now you simplify it. And you should have 32 x raised to the 10th, y to the 5th. Okay? Negative numbers, use parentheses before you distribute. Each term, use parentheses, q to the 6th. And now you should have 4p to the 8th, q to the 12th, because 6 times 2 is 12. Okay, so pause the video now, finish the next 3, and I'll write the answer down. You should have the process, how you distributed the power outside when you demonstrate your work to me. Okay? Okay, that's the answers. Now let's look at the mixed practice. I'm going to move this sheet upward and then make this bigger so that you can look at it easier. Let's look at the mixed practice. With mixed practices, you have to read them carefully and treat them each term based on the theories or properties that you want to apply. So let's look at number 10. I have two variables inside with exponents, and then it gets raised again by the power of 3. So now I'm just going to have to keep this inside, distribute this 3 to that, and then I do the same to my y, distribute the 3, right? Set it up nicely. So now you use the power rule. You should have x to the 9th, y to the 9th, and then copy down the rest of it. Now, in this case, remember we talked about it earlier, we have the same base and then different exponents. So when that happens, what do? We add exponents. We keep the base, we add exponents. That's how we get to the finishing line. Number 11, I will leave it to you and I'll write the answers down. And then I'll do number 12. Okay, so number 12, there are two parts here if you look at this. So take the first part first. Let's try to simplify that. It's negative 2 squared, then a squared, then b squared, the whole thing squared, right? And then there is the second part, which is 3 squared times a squared squared times b squared. Now you start simplifying them. I should have 4a squared. 2 times 2 is 4 here. 3 squared is 9. A squared again. 2 times 2 is 4. And b squared. Now I'm in the situation where I have the same base of a, there, and then the same base of b there. So then I keep the base. First of all, I multiply simplify the coefficients. 4 times 9 is 36. I keep the base. I add the exponents. 2 plus 4 is 6. I keep the base b. 2 plus 4 is 6 again. That's how I get my final answer there. Okay. Number 13, I will leave it to you. There's a fraction in there. Use your calculator. It works the same way. And I will do number 14. 2a squared and then cubed. So it becomes 2 cubed, a squared cubed. Plus here I have a raised to the 4th times 3 times a squared. So it's the same base. I leave the coefficient alone. I keep the base. I add the coefficients. So 2 cubed here is 8. 2 times 3, this is the power rule, is 6. Plus 3a raised to the 6. I have 11a to the 6. Combine like terms, right? My like terms is right here. Number 15, 3/4 x, 3 times 4 is 12, y 4th. Now I change the color to do the second one. I have 7 minus 7 squared is 49. X to the 5th squared is 10. Y squared, and now I time x squared y squared. So I got to simplify this part first. So I still have the minus sign, 49, same base, x squared and x 10th. I add them together, I have 12. Same base, y squared and times y squared, that's y raised to the 4th. I bring the rest of it down. 3 raised to the 4th should be 81. X to the 12th. Y to the 4th. Forgot the parentheses. So this becomes 81 minus 49. They're the same term, right? Like terms. 81 minus 49 should give me 32. Is that right? And then the variable terms are exactly the same. I hope you see that at this point. In Algebra 1, we did quite a bit of this. You can just look at this because their variables are the same, the exponents are the same, they are like terms. Put it in a box, put it in a square or something, and you can just say it's 81 of that box minus 49 of that same box. Obviously, you have 32 of that same box left, right? You have to bring down the like term, which in this case it's x to the 12th, y to the 4th. Otherwise, you have a naked number, which is incorrect. Geometric applications. So we're asked to find the perimeter and the area. So perimeter, I should have, obviously, this is a rectangle. Ugh, I cannot talk. Rectangle. So I have two 12x's, right? And then I have two 5x squares. So I have to add 2 times 5x squared. And that's simply 24x plus 10x squared. For area, it's base times height, so it's 12x times 5x squared. Now in this case, I have coefficients multiplying each other. I have 60, and I have the same base in x, but I have different variables. So I add the variables together. I should have 60x cubed. Number 17, it's a triangle. Perimeter is easy. You add the first leg for a squared b plus the second leg plus the hypotenuse. Let's see. This term and this term are like terms. So I have 14a squared b plus 3ab. That's it. There's nothing more you can do. Now for area, for triangle, it's 1/2 base, which is 3ab, times height, which is 4a squared b. And now numbers first. 4 times half is 2. There's a 3 there as well. So that would be 2 times 3 is 6. So you put it in your calculator. You should have 6. And then you have the same base A, different variables added, same base B added. That's your final answer there. Okay? I will leave 18 alone for you to do. The perimeter should be 60. And then the area is 40. That's the final answer for number 18. Number 19 is a little bit more challenging. I think what I would like to do is to ask you guys to do it, but we will do a demonstration in class. And number 20 is the same way. It's 9 pi x squared y to the 6. See if you can come up with the same solution yourself. After you try it, we'll try it together in class. Okay? Thanks, guys. Bye.